you mean right away? Yeah, I started videoing late. Too bad. You know what? I just went through this again, which you should have watched the video that I shared on Google Classroom, the English guy that describes that. So boo-hoo. All right, here we go. But you did just miss my cramp in my arm. Oh, okay. I'm afraid to write. My hand might seize and break my pen as I get my cramp again. Okay, so a private plane flies at, hey, could somebody in the chat find out what that distance is? Could be a pal and actually tell me that. But we should know rate times time equals distance, right? Oh, last hour took like a half hour for someone to finally write something. Oops, faces on the internet, sue me. I got no money anyway. Yep, still waiting. So 1.3 hours at 110 miles per hour on a bearing of 40 degrees. Okay, so the first thing is this plane takes off. It's going on a bearing of 40 degrees. Visualize that means off the north axis on a piece of paper, it's going northeast. So I'm going to put the starting point of the plane down here. And then the smartest thing to do on bearing questions is put a crosshair on there. Still nobody can multiply 1.3 times 110 for a fella? See, internet, this is what I deal with these high school students. They don't ever want to help the ugly teacher. Thanks, Lindsay. I appreciate it. I should give you a prize when you come to class. I'll spray it with Lysol so there's no COVID on it. And then, yeah, my hand's all shaky from my little incident here. Arm cramping up. So 40 degrees that direction. Whew, there's the plane flying. Right? And then what Lindsay just did for me, the rest of you, thanks for not helping. I can put 143, and it is miles because it's in miles per hour. So the plane flies at a bearing of 40 degrees. So you need to put a crosshair there, do the 40 degrees, and then shoot the plane off. And that's what the plane does for 143 miles. Then it turns. I can do the next part and does another 1.5 hours at the same speed on a bearing of 130. So this is what you got to do here. Here's the turn. I need a crosshair. Hopefully you do a better crosshair than I. That's more vertical and horizontal. And then 130 degrees is this. 90, and then another, well, we'll find that out mathematically in a moment. And then it flies. Now, as it's flying, 1.5 times 110 is 165. It is nearly impossible that this plane ends up directly east of itself as where it started. So I'll tell you where people go wrong on this, what they do incorrectly. I would say maybe right around there. So everyone's triangle should look the same. Where do you end this? I don't know. You could end here, could end here. I don't really care about that too much. It's more about the plane is right of where it started, and this is how the triangle is constructed here. I'll say it stops here. Oop. And then I'll get that one, I think it's 165, 1.5 times 110. So that's 165 miles. And then the question is, how far is it from where it started? This is what I mean. This is not 50 degrees because you are not directly east of where you started. That is not a horizontal line. It is nearly impossible. Like when the plane's flying, it could be here, here, here. Now it's directly east, but now it's not because it kept going. See, that's what you have to understand. It's nearly impossible to be directly east of where it started in this little thing. And that's what students do wrong all the time. Okay, and then we're done. Not yet, though. Put in the chat, hopefully a little faster than the calculator help here. How come I know, this is the next part that you have to do. How come I know that this angle measures 40 degrees? What's the relationship between those two angles that I could say this is 40? We'll wait for the chat. 2:19. What time do we get done? 2:30? Okay, when should you go to the dentist? 2:30. 2:30. Oh, I said that one last. Well, we got two new kids, so you know, to share that joke to the new kids. No one's gonna answer? Nice, thanks, Nadia. Much appreciated. And then Modest, yep, you two is almost a tie. They're alternate interior, so yeah, that ends up being 40 degrees. And then, okay, this is 130. So how do I know this is 50? because this would be a 180 from north to south. That's why we need these crosshairs. Those two angles added together are 90, so yeah, you have a 90-degree angle. Hence, this is why this is in Chapter 2. We only are doing right triangle trig in Chapter 2. So these bearings, they do end up having to be a right angle in there so that we can do right triangle trig. I'll tell you right now, this is worth 2 points on your test. 1 point is actually the trig, or not the trig. I have to find x, and I have 2 out of 3 sides in a right triangle. It's actually the Pythagorean theorem. So that could happen on your test. Not necessarily trig, just can you draw the drawing and understand that it's Pythagorean theorem to solve for this. Okay, so it's really about the drawing. Yes, you're going to get a right angle. Some people are going to assume the right angle and feel that they don't really have to know how to do bearings tomorrow or Friday. They get away with it a little bit, but in Chapter 7, they will not be right triangles. So you will have to be able to find these angle measures through some simple geometry. And then that won't be 90, and then we'll talk about, I think you've seen the law of sines and cosines before, but that's going to be in May. We'll worry about that. Think about that, May, February, March, April, May. Oh, I can't wait till March and the St. Patrick's Day. That's just like a great checkpoint for we're getting close to spring break, and then after that, it's the final push. Oh, I get excited at St. Patrick's Day. Anyway, give you a chance to write this one down. There outside of the beautiful day. Did I say bundle up this weekend? It's supposed to be like minus 30 degrees Saturday or Sunday. Purple out there, kids. Ready? Okay. 2, 5. Now this is a tricky one. And if this was standard notes, if you watch the 30-minute video, I bet you know a little bit. And I'm kind of abrasive in that video. I'm just weird in general. But I think I go over one where you got to be careful on this. You have to think about it first before you start drawing. So 2 fire spotting towers 18 kilometers apart. Fine, I got a length. Good. From Tower A fire is seen on a bearing of 300 degrees. So we're back to that first way. Tower B, the same fire is spotted on a bearing of 30 degrees. Okay, so let's think about those 2 bearings. This is my head. I'm not physically writing this on a paper normally, but I am for you and going through my thought process. Good, the pen's barely working. 300 degrees would be off of the north axis. What is going on? There we go. And looking in this direction, pen is half working. Not sure what's happening there. So that's from Tower A. So that's from Tower A. And then Tower B, well, that's an accident. Let me put this like below here. From Tower B, the bearing of the same fire is 30 degrees T, and that's B. So where is B and A? Is B left of A or is A left of B? Like who's where according to these lines of sight? And it actually is B is over here. It's the only way that the fire can be in the position that's said to be located at. So B and A are in those positions on an east-west line. Because if you would have put A on the left and B on the right, then A would be looking over here and B would be looking over here, and it's supposed to be looking at the same fire. So that would be your first mistake. Wait a minute, something's wrong. Something that says A has to be on the left. So that's the problem there. Okay, so those that picked up on what bearings are, you know what I just said there. So I am going to do the crosshair. It looks like I already did do a crosshair on B. So here's B, Tower B, 30 degrees clockwise, line of sight. And you do want to draw like just a full ray until you see the cross section from A's line of sight. And A's line of sight is 300. So that's that 270 and then another, well, we should know, another 30. Ooh, not a straight line there. My pen is acting weird now. The exact opposite of the last question. Nearly impossible for this to be a direct east-west line when the plane's just flying in the air. So you cannot call this 50 degrees. 40 plus 50 equals 90. Heck no. This is the exact opposite. This is a direct east-west line as stated in the question. So if this is 30 degrees, then this is 60. And then if this is 300 degrees, that arc that I drew there, 270 and take away 300, that's 30 degrees. Oh, so that is a right angle right there, 30, 60, 90. Okay, and then some things I didn't write. Oh, I didn't write 18 here. They are 18 kilometers apart. So again, I wouldn't draw this. This was my thought that I'm erasing. That's why I knew B is to the left, A is to the right. All right, with all that being said, it said which tower is closest to the fire. I bet you some people know the answer without trig. Side opposite to 30, half of the side opposite to 90. Side opposite to 60, 9 times root 3. So this one is the longer side. Or, I'll change colors. If you didn't think that, fine, do trig. X, Y, X, let's take 30 degrees. That would be sine then. This is why this is only worth 1 point. The solving of these is very simple. Sine of 30 equals X over 18. Guess what the sine of 30 is? Don't guess, you should know. Sorry for pointing at you. Sine of 30 is a half. Half times 18 is 9, which I already wrote there because of 30, 60 analogy. Cosine of 30 is Y. I think I called that Y over 18. Cosine of 30 is root 3 over 2. Root 3 over 2 times 18 is 9 root 3. But you'd probably put a decimal. That's fine too. I'm not telling you have to do 30, 60, 90. Done that. I was just, talking out loud. Now most people talk out loud. Then I'll draw this one. Probably put how you solve it too, because it's after you get the drawing, it's easy. So you think first. Oh, first of all, 2 lighthouses, 20 kilometers north-south line, so they're above and below each other. Ooh, which one's where? Well, it tells you in this one. It's easier. The northern lighthouse, spots of fire or ship. Hopefully the ship's not on fire. And a bearing of 130. Okay. All right. 130 means the fire on the piece of paper is to the right. So I feel confident drawing this now. So I have 2 lighthouses. The one on the northern, I'm not even going to label it. It's just the one up above on the north-south line. So that's why everyone should have the same triangle. How could we not have a line going up and down? Emily left. She always leaves. Aw. Okay. It must have been something I said. 130. And then line of sight. You can go as far as you want. I don't care. 130. Again, hammer down in bearings. Off of the north axis clockwise. By the way, the same measure would be, hey, this is a north-south line, so I can do this. And this is something we're going to have to find. That is 50 there. Another way of expressing this is off of the south axis, south, 50 in an easterly direction. So feel free to insert that in there, that's another way I could have expressed that. And then the southern one, it's 40 degrees T, which this is easy the other way. Off of the north axis, 40 degrees in an easterly direction would be another way of saying 40 degrees. I don't know. Okay, and then you know what? That is in the triangle, so this is 40. Did Emily come back? She is out of here. Ooh, ooh. Remember, I have to yell at her Friday, second half of the alphabet. Adriana, you seem that you can do that for me, right? We got to yell at Emily? Okay, good. Got you in.
The computer died.
Oh, of course. Who told? What, did she text somebody?
She asked for the code again. So
she what now?
She had to ask for our code.
Oh. Okay, good. I can yell at her today then. All right. 10, 90, because 50, 40, 90. All right, 20 miles or 20 kilometers. Okay, now this one is trig and it's 40, 50. That's nothing special, so pick one. So distance from the northern, we'll call that X. I'll pick 40. Sine of 40. Why this is only worth 1 point. It's so simple after this. Sine of 40 equals X over 20. So 2 points for the drawing, just to see that you get the bearing and understand how the triangle is supposed to look. And then for Y, cosine of 40. And I think the cosine of 40 is bigger than, yeah, cosine of 40 is bigger than the sine of 40, so the bottom lighthouse is farther than the top one. Okay? Alrighty. Yes, that's it. Oh, and that was easy too. This is certainly smaller because it's opposite the smaller angle. Stupid. All right. I guess we're done. Like I said, you have a lot of options to relearn this. Did Emily come back? Emily, where'd you go? You need to plug that sucker in. Okay. All right. Oh, I got you in. You're on the movie now. All right. I'm done. I'll see you guys, blabbering. Sorry for was it this back that my arm cramped? Sorry if I scared anyone. Boy, that scared me. Oh, it hurts. There we go.